this is the question. We have to find out the value of current I. At the same time, अभी हम जो भी क्वेश्चन सॉल्व करने वाले हैं उसमें whatever might be asked in the question, but our focus will be on proving that power absorbed is equal to power delivered for any given network, right? Because whatever is the power absorbed will be the power delivered by the other elements. So the energy of the entire system must remain conserved, that is law of conservation. Whatever is consumed must be delivered in the equal amount. So the focus will be on proving the power balance और उसी process में I अपने आप निकल करके आएगा. Now see what we know till now. We know the basics of KVL, KCL, power absorbed, power delivered, potential and potential difference, right? This 6 things we know: power absorbed, power delivered, KVL, KCL, potential difference. These basics that we have studied so far are now to be used in the particular numerical problem solving. So इतनी चीजें अब हमें अप्लाई करनी है. Generally, whatever is the bottom node is assigned as a reference in maximum number of cases. So जहाँ पर भी हमें reference define करना हो, we generally take it at the bottom, although any node can be taken as a reference node. Usually जहाँ पर सबसे ज़्यादा number of branches meet करती हैं उस node को हम reference node लेते हैं. तो generally maximum number of cases में हमें bottom पर ही ये node ले लेना होता है, because moreover circuits are like this only. So we have to now solve the circuit in the minimum number of variables. When I say minimum number of variables, I mean to say minimum number of equations. So we have to write minimum number of equations to solve a particular problem. So if I have to solve this in minimum number of equations, here we shall focus on the branch currents. We will pay attention to the current flowing in each and every branch. So if this is I given to me, this is I and this is 4, then this current must be I plus 4, right? If I look at this node, if I is going that side, 4 is coming this side, then I plus 4 simply comes from this side, which is nothing but your KCL, right? Now एक ऐसा लूप हमें अब लेना चाहिए जहाँ के सारे वोल्टेज ड्रॉप्स या वोल्टेजेस हमें पता हो, ताकि उस लूप के अंदर हम वोल्टेजेस के एल्जेब्रिक सम को 0 कर दें. तो इस करंट सोर्स का वोल्टेज अभी हमें नहीं पता, लेकिन अगर आप इस लूप को देखें, दिस पर्टिकुलर लूप, यहाँ पर वी नो all the polarities and the voltages, right? So if you just look at the direction of current, this voltage drop must be like this. This voltage drop must be like this, and this voltage drop must be like this. Is this okay? So starting from the positive of 50, we shall have 50. From plus 50 we start, प्लस आता जाता है तो माइनस 3 I plus 4 minus 5I plus 10 is equal to 0. So this can be solved as 8I is equal to 50 minus 12, that is 38. 38 plus 10 is 48. So I comes out to be 6 amperes. तो I की वैल्यू इस तरीके से 6 एम्पियर आ जाती है. हमें ध्यान रखना है, as I said, we have to solve the numerical and minimum number of variables, therefore minimum number of equations. Moreover, in more than 95% of the cases, especially the problems which have appeared in the exam of GATE, we will have to write only one equation. At the most 2, not more than 2 equations we are going to write. Only by writing 1 or 2 equations we shall solve the entire numerical problem. Is this okay? Now this, if I is equal to 6 amperes, I can substitute this I back here in the circuit and let me redraw the circuit. हम इस सर्किट को थोड़ा रीड्रॉ कर लेते हैं. I am putting I equal to 6 now. So when I is 6, so 6 plus 4 becomes what? It becomes 10 amperes. So redrawing the circuit, this is 4 amperes. So when I put I equal to 6, it comes out to be 10 ampere, out of which 6 ampere goes here and 4 ampere definitely goes that side, so that this branch current is 4 amperes due to this current source. So one thing is quite apparent now: who is delivering, who is consuming. Now if I pay attention to this circuit, I have to now prove the power balance. So first of all, let me first identify which circuit elements are delivering and which are consuming the power. I must know the voltage across the element and the current flowing through the element. As you can see, 50 वोल्ट के पॉजिटिव से 10 एम्पियर आ रहा है, तो 50 into 10, 500 watt is delivered by this voltage source. This 10 volts, you can see 6 amperes comes down like this. So 6 ampere is coming out from the 10 volt positive polarity. So 10 into 6, 60 watt is delivered by it. The only thing that we don't know is this current source. So far as question of the resistances are concerned, resistances will always consume power. Is it okay? It is only the independent sources which we are looking at to find out whether they are absorbing or consuming. So I have to find out the power absorbed or delivered by this current source, means the voltage across this current source. If I am somehow able to find out, then I can find out whether this current source is absorbing power or delivering power. So this again is your reference. As you can see, voltage at this point is 50 volt with respect to reference. This is 50 volt at this point. This voltage drop must be 30 volts. So if this is 50, this is 30 volt drop, then this node voltage must be 20 volts. This has to be 20 volts. If this 6 amperes comes down like this has to be 30 volts. This has to be 30 volts. Since this is 20 volts, there is no element here, so it is like a single node. It is one single node where the potential is 20 volts, the absolute potential. There it is like a single node having a single potential of 20 volts. So if this is 20 volt, this is minus 30, so this has to be minus 10 volt, which is already the case because of this voltage source. तो यहाँ से cross verify भी हो गया that this voltage source is minus 10 volts. If this 4 amperes comes out like this has to be 8 volts. Is it okay? So 20 minus 8, this voltage has to be what? 12 volts. The potential at this point must be 12 volts. And see, if this is 12 volts, then this has to be written across this current source in a way like this, so that this 12 volt is with respect to reference and this 12 volt is entirely across the current source. Is this okay? So you see, this 4 ampere current source is consuming. So what we can write is, there are some elements which are consuming power there are some elements which are delivering power. So the consuming elements are this current source. So this 4 ampere current source is consuming 48 watt is being consumed by the 4 ampere current source. Is this okay? The resistances are consuming. How much does a resistance consume? I square R. Current squared into R is the power consumed always. So if you look at this 2 ohm resistance, how much is the current flowing through this 2 ohm resistance? 4 ampere. So 4 squared into 2 is 32 watts. If we look at 3 ohm resistance, it is consuming 10 squared into 3, 300 watts. If we look at the 5 ohm resistance, the 5 ohm resistance is consuming 6 square into 5, so this has to be 180 watts. Is this okay? Delivering, the two voltage sources are delivering 50 volt ke positive se 10 ampere is coming out. So 50 volt source is delivering 50 into 10 is equal to 500 watts. 10 volt source is delivering 10 volt ke positive se 6 ampere is coming. As you can see, this 6 ampere is definitely coming this side. So this is like 6 amperes. Is this okay? So 10 into 6 is equal to 60 watt. So there are 6 circuit elements. There are 6 circuit elements in this circuit. So there are 6 entries. Now if you can see, when you add 48 plus 32, it comes out to be 80. 80 plus 180 comes out to be 260. So this sums up to what? 560 watts, and similarly this sums up to 560 watts. Is this okay? So the summation of the two sides is 560 watts. It means the power absorbed is equal to power delivered in the circuit. So this is how potential difference, KVL and KCL be applied to the circuit to prove the power balance. Once you prove the power balance, everything is just calculated. There is nothing left to be calculated. So you can just pay attention to the results. I said the resistances will always consume power. The voltage sources and current sources, it depends whether they will consume or deliver. For this we have to find out the respective polarities of voltages and respective direction of currents. See, this is the circuit given to us. Now we have to find out, definitely we have to prove the power balance, and say this is point A, this is point B, this is point C. We have to find out the various potential differences, but on a larger scale we have to prove the power balance. Once you prove the power balance for the circuit, everything is just evaluated, all the potentials, all the potential differences. So we have to balance the voltages in a closed loop. We have to balance the currents at a particular node. That's what we have to do. तो किसी भी एक नोड को पकड़ के या किसी भी एक लूप को पकड़ के हमें स्टार्ट हो जाना होता है. Now see, one thing which we can write, if this is 2 ampere entering into B and this is 1 ampere going down, दो में से एक इधर गया तो बचा हुआ 1 ampere must be going in this direction. Is this okay? If this is 1 ampere going in this direction, then this voltage across this resistance must be 3 volts. Alright, these are the information that we get to know once we look at the circuit. So the currents are balanced at this B the 2 ampere goes into it and 1 plus 1 2 comes out from it. Is this okay? Now we have to find out other branch currents. For that purpose, what we can do, we can say that this current is, say, I. If this current is I, we have assumed it to be I, 2 goes here, so I minus 2 goes here. So I minus 2, this I minus 2 reaches here. I minus 2 and 1 is coming from this side. So this becomes what? I minus 1. I minus 2 और 1 ऐड हो जाएंगे, तो I minus 2 में जब आप 1 ऐड करते हो तो it simply becomes what? It becomes I minus 1. Alright, now let us take this outer loop. So when you take this outer loop, what do you get? 80 minus 2I minus 4 minus 2 I minus 1 minus 15 is equal to 0. Is this okay? So this comes out to be 4I on one side. So this is 76 and it is 61 I think plus 2. So this has to be 63. 80 minus 4 is 76 plus 2 is 78 minus 15 is 63. Is this okay? So I is 63 by 4 amperes. I is 63 by 4 amperes. Is this okay? So if I is 63 by 4, this can be written as 15. This has to be 33, then 3 by 4 is 0.75 I think. So this has to be 15.75 amperes. Is this okay? So 15.75 amperes is the current. Is this okay? If we take this current to be 15.75 and if we redraw this circuit, then so I can write these values as it is. This is 15 volts and this is 1 amperes. Now I am simply putting I is equal to 15.75 and drawing all the, indicating all the currents. So this has to be 15.75 amperes. So this must be 13.75 amperes. So 13.75 amperes comes on this side. This is anyway 1 amperes already indicated. So 1 plus 13.75 will become 14.75 amperes like this. Is this okay? Let me take this as the reference. Is this okay? So this potential can be evaluated as, this is a voltage of 80 volts at this node. Alright, so this voltage drop 15.75 into 2 is 31.5 volts. So when you deduct 31.5 from 80, you get 48.5. 48.5 is the potential here. If you further deduct 4 from 48.5, you get a voltage 44.5 volts here. So these are absolute potentials at this point. 48.5 में से when you deduct 4, you get 44.5. So this is 44.5. This 14.75 is coming down like this. So if you see, this voltage drop has to be 29.5 volts, and 44.5 minus 29.5 is anyway 15, which confirms that we are doing the calculation in the right manner. Is this okay? So this voltage source has to be 15 volts because this potential is 15 volts. This confirms our calculation. Now this voltage, as already indicated in the previous diagram, this is 3 volts here. If this is 3 volts, this voltage has to be 44.5 plus 3, so this has to be 47.5 volts. This voltage is 47.5 volts, so that the voltage across this current source is 47.5 volts, because this node is the voltage across this current source only. And you can see the 2 ampere current source 48.5 इसके लेफ्ट में है, 47.5 इसके राइट में है. So we must have 1 volt. This is 1 volt. Is this okay? So in this way we have calculated all the currents through each and every branch of the circuit, voltage across each element and current through each element. Now let us calculate the power absorbed and power delivered by the circuit elements once we have calculated the current through each branch. So writing the 80 volt source, now which are delivering, which are consuming, we shall write delivered on one side and consumed on the other side. So delivered on this side, consumed on this side. Alright, so first of all, when we say consumed, all the resistance must consume, so we must put all the resistances in this column. So 2 ohm, as you can see, is consuming this much watts of power. You can do the calculation part. If you see 3 ohm resistance, 3 ohm resistance is consuming, this is the current flowing and into 3, this much of watts, and the 2 ohm, this 2 ohm is that extreme left one, this 2 ohm is the extreme right one, this one. So this one is consuming 14.75 squared into 2, this much of watts. If you look at the current source, this current source is having a voltage drop of 47.5 across it and 1 is coming into it. So this current source must also be consuming. So if you see the 1 ampere current source, it is consuming 47.5 voltage into 1, this much watts of power. If you see 2 ampere current source, 2 ampere के positive में 1 volt के positive में 2 ampere is entering, so it is also consuming this 2 ampere. So this 2 ampere is consuming 1 into 2. For the voltage and current sources, we simply follow a convention. We write the voltage first and then the current. Is this okay? You can write it either way, but just a convention. We write the voltage first and then the current, because V into I dimensionally is what the power is. Is this okay? So this 2 ampere is consuming. If you look at this voltage source 4 volt, this 4 volt source is also consuming. How much is it consuming? 4 volt is consuming 4 into 13.75, this much of power. If you look at, we have done this current source, this current source. Look at this 15 volt source, which is at the extreme right. This 15 volt voltage source is also consuming, it is consuming 15 into 14.75, this much of amperes. Is this okay? There is only one source which is delivering here, and it is this 80 volt source. So this 80 volt source delivers 80 into 15.75. This much of watts is delivered. Is this okay? So this much is the power delivered by the voltage source. So if you see, it comes out to be 1260 watts. This much is delivered. We can always cross check. There are 8 circuit elements, so we must have 8 entries. So 3 plus 3 is 6, 7 and 8 entries are there. If you just sum it up, this calculation you can do. If you take the sum of all this, the sum will come out to be 1260 watts, which proves that power absorbed is equal to power delivered for the circuit element for the particular circuit. Is this okay? Say this is the problem given to us. We have to find out the current I, as well as we did in the last two problems, we have to prove the power balance. Is this okay? The main aim is again to write the minimum number of equations. So minimum number of equations we must write. Now see, we have to start from some node or some loop of the circuit. Just see this. If 2 going that side, I going this side, so this has to be I plus 2. This has to be I plus 2, so that this is I and this is 2. Is this okay? 2 reaches here, 4 reaches here, so this must be 6 amperes. This has to be 6 amperes. And if 6 is reaching here, out of which I goes there, so I must have this as 4 minus I. Is this okay? When you subtract I plus 2 from 6, so it's like 6 minus bracket I plus 2. So 6 minus bracket I plus 2, when you simplify, it comes out to be 4 minus I. Now we can write only one equation to evaluate this I. So again I have to choose a loop where I know all the voltages. So if I simply take, say, this loop, I traverse this loop in the anti-clockwise direction. So say this is the direction of traversal of the loop, like this. I start from the positive of 3 volt and I traverse. So I would write, starting from the positive of 3, so 3 minus 2I, and then it goes, this voltage drop is like this due to this current, so I will have a plus here, 3, 4 minus I, and this has to come out to 0. So this comes out to be 5I, and it is 15, so I comes out to be 3 amperes. So the value of I comes out to be 3 amperes. So as I said, we have to write minimum number of equations, one equation, and definitely not more than two in the numericals to follow. So I now comes out to be what? 3 amperes. Now see, you can choose this as the reference. Again, this is your reference. So 4 minus I, now I am doing it directly. 4 minus I must be 1 ampere since I is 3. So this must be 1 ampere. If this is 1 ampere, this voltage here must be 3 volts. This has to be 3 volts here. This must be 3 volts, right? 4 minus I is 1 ampere. 1 ampere flowing through 3 ohm. This will be 3 volt plus on the upper side minus on the lower side. So this has to be 3 volts. Now this voltage drop, as you can see, the current flowing in the 4 ohm resistance is 6 amperes. So this voltage across 4 ohm must have this polarity, that to a 24 volts. So 3 plus 24 has to be 27 volts. This 27 volt is entirely across this current source. So this is 27 volts. This, since this is 3, this must be 6 volts. Now you see, it is 6 volt, it is 27 volts, it's a difference of 21 volts. So this has to be 21 volts. This voltage must be 21 volts plus on the side which is on the higher side 27. So a 21 volt is there directly across this current source. Is this okay? So in this way, this I plus 2, since I is equal to 3, then this must be 5. So this is 5. Is this okay? And this I is anyway 3 amperes. Alright. So again, you can prove the power balance such that we can write delivered on one side and consumed on the other side. On the consumed side, we must have all the entries of the resistances, since resistances will always consume. So 4 ohm is consuming 6 squared into 4. So this comes out to be 144 watts. If you see 3 ohm, 4 minus I is 1 ampere. So 1 ampere flowing through 3 ohm. So this is 1 square into 3, that is 3 watts. For 2 ohm resistance, it has to be 3 squared into 2, 18 watts. So this finishes all the resistances. If you see the voltage sources and the remaining two current source, they are delivering. So if you see 2 ampere, 2 ampere current source is delivering 21 into 2, that is 42 watts. If you see 4 ampere current source, it is delivering 27 into 4. So this is 108 watts, and 3 volt source is also delivering 3 into 5, that is 15 watts. Is this okay? So this is like 123, 125 and 165. The total of all these comes out to be 165 volts, 165 watts, sorry. The total of power comes out to be 165 watts. If you see on this side, this is 144 plus 3 plus 18, it also comes out to be 165 watts. Is this okay? So in the beginning, when you are practicing, you only have to focus on proving this power balance. Whatever is consumed in the circuit must be delivered from the circuit. This is one of the previous questions from the examination of gate, where we need to evaluate this value of PS. Alright. So there is some data given in the question itself that this is 2 amperes. Now if this is 2 amperes, 1 ampere comes out from here, then this has to be 3 amperes. Alright, if this is 3 amperes, this must be 18 volts, and since this 2 ampere is going like this, it must be 12 volts. So we can simply traverse this loop, the right hand side loop in the anti-clockwise direction. We can simply start from the positive of Vs, so that we can write Vs minus 12 minus 18 is equal to 0, so that Vs comes out to be 30 volts. Is this okay? So the answer to this question is 30 volts. Of course, you can move forward to proving the power balance, which we have done in the previous set of numerical problems. So we have some numerical problems from the previous year GATE papers. See, the problems are written in front of you. Some values are known to us, some are unknown, which are to be calculated. Now see this particular question, question number 1. It is asking us the value of this Vs. Is this okay? Now there is one more thing given here. We have this given to us as 16 volts. This is given us in the problem itself. Alright, so this data is given and we have to find out this Vs. How to calculate this? It's again quite easy. You can simply apply KVL here. If you simply apply KVL here, you can have, say I traverse this loop clockwise, so Vs minus 16 minus 5 is 0, so that Vs comes out to be 21 volts. Vs comes out to be 21 volts. Is this okay? Now the question finishes here, but कुछ और चीजें हम इसके आगे भी निकाल सकते हैं. See, if this is 16 volt, this is 2 ohms, then this has to be 8 amperes. This voltage anyway is minus 16 volts. This is minus 16 volts. If this is minus 16 से 2 ज़्यादा, minus 16 से 2 ज़्यादा is minus 40 volts. This is minus 14 volts. Is this okay? This is minus 14. If you see, this is your reference, so this voltage here must be what? This is 10 volts. तो 10 और minus 14 के बीच का difference आप देखें तो it is 24 volts. So 10 on this side of the resistance, minus 14 on that side of the resistance. So this has to be 24 volts. 10 minus minus 14 is equal to plus 24. So this comes out to be how much? This current through this resistance. What is the voltage drop across the resistance? 24. 24 divided by 1 is 24. So this current must be 24 amperes. So this is 24 amperes. Is this okay? This 24 amperes reaches here. 8 gets added to it. So when the 8 gets added to it, 24 plus 8 is 32 volts. So this is 32 amperes, sorry. So this is 32 amperes. Is this okay? And this is 21 volts. Again, you can do that exercise, who is consuming, who is delivering, and you can prove the power balance. Although the original question that was there for 1 mark, it asked only for the value of Vs. Other things you can evaluate. As I said, when you are solving DC circuit problems, you can always prove the power balance for the circuit. Once you prove the power balance, there is nothing remaining to be calculated in the circuit. If you see this, now this would require the current division rule. Now see, the value of resistance has to be calculated here. Alright, now see, what you can do is, this is 2 amperes, this is 10 ohms. Alright, so if this is 2 amperes, this is 100 volts and this is 10 ohms. I have to find out the value of R. So let me just look at the given data, whether some data is missing. So the value of R has to be evaluated and it needs to be cross checked. We have to find out the value of R. This is 10 ohms, this is 10 ohms. Alright, and the options are 20, 10, 20, 30 and 40. Alright. So this voltage drop must be what? 2R. This must be a 2 into R is the 2R voltage drop. This is what? 2R. The voltage here is 2R with respect to reference. Since it is a potential difference, let us not encircle it. Since it's an absolute potential, we are encircling it. So this voltage is 2R. So this must be 2R by 10. This current 2R by 10 is 0.2 R. So 0.2 R and 2 going that side. So this has to be 2 plus 0.2 R. Alright. So we can simply apply KVL here. So applying KVL will give you 100 minus 10 into 2 plus 0.2 R, and I can simply finish it here in this loop, minus 10 into 0.2 R, and it has to be equal to 0. So 10 into 0.2 R, 10 into 0.2 R, so it's like 4 R. So 100 minus 20 comes out to be 20 ohms. So the answer to this question is 20 ohms. Is this okay? Now, before we move on to this question, let us first have a review of the current division rule, which I think you are familiar with. Whenever two resistances are connected in parallel, you have a current division between them. How does the current division take place? The more amount of resistance will have lesser amount of current flowing through it, and the lesser amount of resistance will have more amount of current flowing through it. So there is a parallel combination here which we shall be dividing the current between. So we must have a review of the current division rule. What is current division rule? If you have some current I which is to be divided between R1 and R2. Now the voltage across them must be the same. This is the voltage. Say this is the voltage V or Vs as you want to call it. This is the voltage Vs. This is say the current Is. This current Is is divided between the two resistances. So this has to be I1 and this has to be I2. So as you know, I1 is and I2 is it's like this. Is this okay? So if there are two same resistances, say this is 4 ohm, 4 ohm, so it will be simply Is by 2, Is by 2. So the currents are divided in the inverse ratio of the resistances. Now if you look at this particular problem, we have to find out this value of Vs, right? So since this is 90 volts given to us, 90 divided by 18 is 5. So this is 5 amperes. This is 5 amperes. Is this okay? We have to find out this value of Vs. Now this is a ratio of 1:2. Is this okay? So this 5 ampere must be divided between these two. If you see, we can either divide this 5 ampere between these two using this relation, or we can directly solve this parallel combination since we have to find out this Vs. 6 and 3 in parallel, it's like 6 into 3 upon 6 plus 3. 6 into 3 is 18, 6 plus 3 is 9. So 18 by 9 comes out to be 2 ohms. So it simply is a single resistance of 2 ohms. Alright, we don't require individual current, so there is no need of current division. You can divide the currents if you want. So this voltage drop has to be what? This has to be 5 into 2, 10 volts. Is this okay? So this is 90, this is 10. So this voltage, therefore this voltage has to be 100 volts. Because this voltage here is 90, 90 plus 10 is 100. So this potential is 100 volts. This 100 divided by 5 is 20 amperes, because this 100 volt is basically this 100 volts. So this is 20 amperes. You can see this is 20, this is 5. So this must be 25 amperes. If this is 25 amperes, this must be 25 volts. So I can simply have this loop, or you can take the outer loop as the case may be. If I take this loop, simply it's quite visible. Vs minus 25 minus 100 is 0. So Vs is 125 volts. Alright. So this is the current division rule which you can use. हमें यहीं पर वोल्टेज डिवीजन रूल भी देख लेना चाहिए. व्हाट इज वोल्टेज डिवीजन रूल? वोल्टेज डिवीजन रूल, द वोल्टेज गेट्स डिवाइडेड इन अ loop. In a loop, the voltage gets divided. How does it get divided? Say this is Vs, the very first case that we saw. Say this is R1, this is R2, current being the same. This is, say, voltage V1, this is voltage V2. So what is V1? V1 is this, it's like this. So what is written on the right side of U is called as the current division rule. What is written to the left side is called as the voltage division rule. Is this okay? Alright. So let us take some examples from previous year GATE. 4 problems written in front of us. We shall solve it one by one. Let us have the first two which are visible on your screen. We have to find out the value of this current I, and this is the data given to us. There is one more data which we have given in this particular question. As you can see, there are 4 parallel branches of 2. So we have 1 ampere flowing through the resistance 4R. So this is 1 ampere given to us. Alright, this 1 ampere is already given in the question. So we have to find out the value of I. This I has to be evaluated, this I. Now see, this is 1 ampere. As you can clearly see, 4R and 2R, they are connected in parallel. If they are connected in parallel, and if 1 ampere is flowing through it, we must have 2 ampere flowing through it, right? This must be 2 ampere. Half is the resistance, means double should be the current. If this is 1, this is 2, this has to be 3 amperes, this has to be 3 amperes. Is this okay? Now if this current is I, this current must be half of this I, so this should be 0.5 I. Is this okay? This has to be 0.5 I. So this must be 1.5 I. Is this okay? So this has to be again 1.5 I. Now see, This is 3 ampere. This is 2 plus 1, 3. Now, one thing we can observe, this 2R, this 4R and this 4R, they are in parallel. You can simply see this. You have one node of all the resistances connected here. You have other node connected. This is a single node. So this 4R must have this 1 ampere current flowing through it because they are all in parallel. So if this is 1 ampere, this has to be again 1 ampere. So if this is 1 ampere, this is 3 ampere, KCL at this node will give you that this is 4 amperes. Is this okay? I think this I, we do not need this information. We can just remove this. Now see, this voltage is how much? This voltage is 4R. 1 into 4R is 4R. 4 into 3R is 12R. So this is 12R. If you see this is your reference, this is 0 volt. So this must be 0 volt, this must be 0 volt and this must be 0 volt. This entire thing is the reference up to here. This is 0 volt. Is this okay? So with respect to reference, if you see, the potential here is 4R with respect to reference. So 4R plus 12R becomes what? 16R. Alright, so the potential, this is 16R. I have to simply find out this I. So this I is simply what? 16R, the voltage here, minus the voltage here, which is 0, divided by 2R. So the potential here, which is 16R, the potential here, which is simply 0 volts, this is 0 volts. So this voltage minus this voltage divided by 2R is I. So this simply comes out to be 8 amperes. So the answer to this question is, the value of I is 8 amperes. Next question is quite easy. You can simply see 8 amperes, this 10 and 10 are in parallel. 8 ampere will simply get divided. So this will be 4 ampere, this will be 4 ampere. So this has to be 40 volts. Simply apply KVL here. So 100 minus 8R minus 40 is 0. So R is how much? 60 divided by 8. That is 30 divided by 4. That is 77.5 ohms. So 60 by 8 comes out to be 7.5 ohms. Is this okay? Moving on to the next question. Now again see, we have this as the parallel combination, right? This is 4 ohm, this is 1 ohm. It is 1:4. Lesser is the resistance, more is the current through it, and vice versa. And it has to be, current has to be in the ratio of resistances since they are in parallel. So it is 1:4. So 4 times of 2 ampere must flow through this 1 ohm. तो ये हो जाना चाहिए 8 एम्पियर. तो ये हो गया 8 एम्पियर करंट. ये 2 एम्पियर है, ये 8 एम्पियर है, तो इधर से 10 एम्पियर आना ही पड़ेगा. 10 डिवाइड होता है 2 और 8 में. सो दिस इज 10 एम्पियर्स. इफ दिस इज 10 एम्पियर्स, आई मस्ट हैव, see this is 8 amperes, this is 2 amperes, so this is anyway 8 volts from either side. 8 into 1 or 2 into 4, it's either way 8 volts. The voltage drop here across this 1 ohm resistance is how much? 10 volts. So if this is 8, this 10 is having this polarity, so this must be what? 18 volts. This is 18 volts. If this is 18 volts, this 18 volts is across this 6 ohm resistance. So I must have this as 3 amperes. Alright. So if this is 3 and this is 10, then this must be 13 amperes. If this is 13 amperes, this must be 13 volts. And 18 plus 13, 18 plus 13 comes out to be 31 volts. and this 31 volts is this E itself. So you can see this comes out to be 31 volts and this I comes out to be 13 amperes. And these are the answer to this questions. We have to simply start from one of the branches or one of the nodes or one of the loops, and then we can gradually move to the entire circuit to find all the unknown voltages and unknown currents. Is this okay? Now this one is an important question. Let me make some space to solve this particular problem. See, I have to find out the unknown resistance R here. Alright. This is 10 ampere given to me, given and delivered by this voltage source, and this is 5 ampere given to me. Now, before we move on to solving this particular problem, one thing we must find out how to calculate, how to write down the KCL equation at a particular given node. देखिए एक जनरल कन्वेंशन है, say I take an example. Said something like this. आप लोगों ने KCL इक्वेशंस लिखी होंगी अलग अलग नोट्स पे, तो अगर इन दो नोट्स पर KCL इक्वेशन हम लिखना चाहें on these two nodes, say I add a current source here, say like this, or we can have it in the reverse direction, say like this. मैं केवल एक एग्जांपल आपके सामने ले रहा हूं just to demonstrate how to write the KCL equation at a given node where the potential is known or the potential is to be evaluated, as the case may be. Now this, you know, let me take this voltage as say V1, say this voltage is say V2. V1 and V2 might be some positive value or maybe some negative value, we don't know. Once we write the equation and solve it, then only we shall come to know about it. So far as question of directions of current are concerned, we don't know the direction. We only know one direction for sure, and that is this 4 ampere direction, this. Alright. Now, how to write the equations? Generally हम क्या करते हैं, जो directions हमें पता नहीं है, हम उन directions को मान सकते हैं whatever direction we want to. Generally we take the direction of current to be outgoing from the node. Again, it's not a compulsion, you can take whatever direction. It is just that when you solve a particular problem, if you have assumed direction of I like this, you solve it, it comes out to be -6. Suppose the direction of current is like this and it comes out to be -6, it by default means that it is 6 in this direction. Is this okay? So you can assume the direction to be whatever you want to. So V1 के ऊपर मुझे 3 करंट मिलने चाहिए, तीनों के डायरेक्शन मुझे नहीं पता, मैं इसको आउटगोइंग ले सकता हूँ, ये आउटगोइंग, ये आउटगोइंग, ये आउटगोइंग. Is this okay? Coming on to this node, what is outgoing for V1 is anyway incoming for V2. So we don't touch this because we already know this. This is anyway incoming. This current, since we don't know, we call it as outgoing. Is this okay? जब हमने V1 पे डायरेक्शन अज्यूम किए तो तीनों आउटगोइंग अज्यूम कर लिए, इसका आउटगोइंग इसके लिए अपने आप इनकमिंग हो गया तो हमने उसको एज इट इज रहने दिया. ये 4 एम्पियर तो इनकमिंग आ ही रहा है बिकॉज ऑफ दिस करंट सोर्स. ये वाला पता नहीं था तो उसको आउटगोइंग मान लिया. तो जो पता नहीं है यू कैन टेक इट एज आउटगोइंग. Although whether it is outgoing or incoming will only come to know once we write the equations and solve those equations. Is this okay? So when we have to write the equations here, how will I write this current? I will write this current as V1 minus 10 divided by 2 plus V1 by 3 plus V1 minus V2 by 4 and this is equal to 0. This is the equation, nodal equation for V1. अब ध्यान दीजिए, क्योंकि आपने इस करंट को ऐसा माना है गोइंग फ्रॉम V1 टू V2 मींस बाय डिफॉल्ट आपने अज्यूम किया है कि V1 इज ऑन द हायर पोटेंशियल कंपेयर टू V2. Alright, so if the direction is like this, I must always write it V1 minus V2 divided by 4. So whether I am writing it here, since this current is like this only, it will remain V1 minus V2 by 4. So for V2 when I will write V1 minus V2 by 4, which is incoming, plus 4 is incoming, is equal to V2 minus 5 divided by 2, and this is outgoing. This is node equation for V2. Some authors have also given this practice that when you are writing it here, you write it V2 minus V1 by 4. Means when you are writing here, you take it outgoing. When you are writing it here, you take it outgoing. That can also be done, even that's not a problem. But जब हमने V1 के ऊपर इस डायरेक्शन को फिक्स कर दिया, तो V2 पे लिखते समय भी उसको हम फिक्स ही रखें. What is outgoing for V1 is anyway incoming for V2, and since it is flowing from V1 to V2, it is V1 minus V2 divided by the resistance. Current will flow from higher potential to lower potential. अगर आप इसको ऐसा फ्लो करता हुआ मान रहे हैं तो V1 minus V2 divided by 4. अगर आप उसको ऐसे फ्लो होता हुआ मान रहे हैं तो V2 minus V1 divided by 4 हमें उसे करना होता है. Is this okay? So this is how the nodal equations are to be written in general. Now coming to the problem of gate, which is written here, where we have to find out the unknown resistance R. Is this okay? So let me take this node voltage as say V. This is say V. This is 100 volts and this is 40 volts. All right. So बीच वाले नोड के ऊपर जहां का नोड वोल्टेज हमने V माना है, वहां से आप तीनों करंट्स को आउटगोइंग मान लीजिए. So say this currents are outgoing. So how should I write the nodal equation? V minus 100 divided by 14 plus V by 2 plus V minus 40 divided by 1, and this comes out to be 0. When you simplify this, it comes out to be V minus 100 plus 7V plus 14V minus 40 is equal to 0. So this is 8 and 22V, this is 100, this is 560, so this comes out to be 660. So V comes out to be 30 volts. This V comes out to be 30 volts. If this V comes out to be 30 volts, इसका मतलब ये है कि 14 ohm के through, 14 ohm के through, since this is 30, so this current must be going that side. So how much this current should be? Let me just redraw this just to avoid the confusion. Now see, it's quite simple. This voltage is 30 volts. This is 30 volts. So if this is 100, this is 30, then how much should be this potential difference? 130, they differ by 70. So this has to be 70 here, right? This has to be 70, and this is 70 with this polarity. This is 14. So 70 divided by 14 comes out to be 5. So this current, this branch current must be 5 amperes. So 10 amperes reaches at this node, out of which 5 goes that side. So 5 ampere must be this current. If you see this voltage here, it is 40 volts. Is this okay? So 100 minus 40 is 60 volts, 60. So this comes out to be 60 volts. So the current through this resistance is 5 ampere. The voltage across this resistance is 60 volts. So for this particular resistance you can write 5 is equal to 60 by R, so that it gives you R is equal to 12 ohms. So this is the value of R. R comes out to be 12 volts. So that is the answer of this question, 12 volts. If you again see, we have to write only one equations. In no case do we have to write more than one or at the most more than two equations. हमें सारी problems one equations में ही solve करनी है. जरूरत लगने पे एक से ज़्यादा equations हम लेंगे.